All right, here we have problem number 13. And this is a good problem. If you're able to work it out on your own, it really does make you feel like you're smarter than the average bear. So let's have a look at it. We're given n is greater than or equal to 0. That is our number of claims. And we're given that the probability of n plus 1 claims is equal to 20% times the probability of only n claims. And we're asked to find the probability that a customer files more than one claim, or in other words, 2 or more claims. So that's our given information, and I've written out a few statements over here that are going to help us solve this problem. This first one is the law of total probability. Probability of 0 claims plus 1 claim plus 2 claims plus as many claims as we want is going to equal 1. And then I've just restated that here with the expression that we're looking for. All of the 2 or more claims right here. So we add up probability of 0, probability of 1, probability of 2 or more than 1 is equal to 1. And then this is the formula for the sum of an infinite geometric series. So let's have a look here, and let's just kind of roll through some iterations of this pattern here. Suppose we start from n equals 0, then that's going to give us 0 plus 1, so p of 1 times, or is equal to 0.2 times probability of 0. And if n is equal to 1, we can do the same thing. The probability of 2, 1 plus 1 is 0.2 times the probability of 1, but we just got a value for the probability of 1. So let's take this value and substitute it in. 0.2 times 0.2 times the probability of 0, and of course that's the same as 0.2 squared times the probability of 0. So this is good because we're writing everything in terms of a single variable. And we'll go ahead and do one more iteration of the pattern. Suppose n equals 2. Then the probability of 3 claims equals 0.2 times the probability of 2 claims. But we have a value for the probability of 2 claims that is 0.2 squared times the probability of 0 claims. So again, 0.2 times 0.2 squared times the probability of 0 claims. And of course, you could probably jump. Oops, let's be sure we use the correct values. You could probably jump straight to this final statement here, 0.2 to the third times probability of 0. But that should be enough to see the pattern. So let's go over here and let's use this first statement, this first expression of the law of total probability, and just start plugging in what we have. Probability of 0, we don't have a value for, so let's leave that alone. But the probability of 1, we do have a value for. P of 1 plus 0.2 times probability of 0. And then same thing for P of 2, 0.2 squared times P of 0. So we're going to substitute that in right there. And that pattern, of course, will go on as long as we want it to and end up summing to 1. So at this point, we can use our sum of the infinite geometric series. A over 1 minus r, the rate of change, so A being the first term, P of 0, divided by 1 minus our rate, which is 0.2, is going to be equal to 1. But let's simplify to P of 0 over 0.8 is equal to 1. I'm just going to do that math on the bottom there. And then if I were to multiply both sides of the equation by 0.8, we would quickly realize that P of 0 is equal to 0.8. So that feels really good. We are halfway home. Now let's go to this second statement. We know that P of 0 is 0.8, so let's do some substitutions. P of 0, 0.8, plus P of 1, well, we have a value for P of 1, that is 0.2 times P of 0. So plus 0.2 times P of 0, which we know is 0.8, plus the value that we want. 2 or more claims, more than 1 claim. That equals 1, 0.8 plus 0.2 times 0.8, 0.96. And finally, subtract 0.96 from both sides. probability of more than one claim, or two or more claims, is going to be 0.04. So, great problem. Makes you feel smart if you get it right. If at some point when you got here, you just decided I'm going to estimate by plugging into my calculator 3, 4, 5 iterations to get a value that's close enough, that's certainly going to work on the exam. This is actually faster, knowing this little formula here and when you can use it, faster, better, cleaner, and when you get to exam FM, unavoidable.